Good morning, everyone. I hope my voice is clear. Good morning all. Are you able to see my screen? Yes. Yes. So far we have 106. Okay, let me start. Right. I received lots and lots of message regarding the pre-requesty topic for the context session too. I really appreciate everyone, right? But the thing is, most probably for the first two to three context session, it's purely a fundamental concept only, right? Moving forward, I'll damn sure I'll share in the slide deck itself, right? For the next contact session, what topics you are supposed to prepare with respect to program as well as with respect to programming point of view as well as mathematical point of view. Okay, but please understand, first two sessions are completely fundamentals. I just wanted to introduce the terminologies, right? Even though I have given some content, it is again, it will be a technical jargon for you. Okay, let me explain the all technical terminologies associated with this particular course in the very first two context sessions so that it will be easy for you to proceed further. Okay, yes. uh, Most probably by next week we can start. If time permits, I will start the linear regression. So for that purpose you should aware of linear algebra. Okay, that's it. Only one topic is mandatory: line equation, polynomial equation, right? At the end, I'll write it in the slide. Okay, for the next context session you should aware of linear algebra. In terms of mathematics, you should aware of linear algebra concept, but programming point of view I'll help you, don't worry. Okay, in the live session itself I'll try to implement something. Okay, yes, shall we proceed? Okay, 137, right? Yeah, thank you. Yeah. So again, I think I have missed some of the topics in the module 1, right? In the I'm actually we are unable to cover those topics, so that is why I have to start with the module 1 and then let me proceed with your module 2 content, which is nothing but machine learning workflow, right? Yes. Before going to actual topic and agenda of today's session, right? In the last context session, we have discussed about so many things. Yes, can anyone type and can anyone list all such informations or terminologies? Yes, Sai Manogar, you can take books from library, in BITS library. Supervised learning. Okay, first machine learning, Anup, right? What is machine learning? Okay, I'll do one thing. For the first 5 minutes, I'll unmute everyone. Okay, you just answer me and then we can proceed. Yeah. Yes, what is machine learning?
Machine learning is like analyzing data and its pattern and provide the output based on that.
Okay, like human, machine will try to learn something new based on the past previous historical data. That's it, right? Yes? Okay, fine. Okay, this is what machine learning. Why we need a machine learning?
Actually, we train the model based on the previous all the data, and we make the some design where the some type of data we can fit, and we can test it, and we can try to
That
automate
is,
the.
I agree. That is the entire flow and process of machine learning and the proper definition and flow of machine learning. My question is why we need machine learning? Instead of human
Uh,
learning, why we need machine learning?
Yeah, where human calculation is not
Possible, applicable. Yes.
yeah, applicable
Yes.
on most of
To work with
in
large data
And
sets.
larger data, right?
Yes.
In that context, machine learning is
also
much more
to
helpful.
avoid continuous changes in the codes.
Yes. Yes. Super.
For making
Because
better
machine will
decisions.
automatically learn without the intervention of human, right? So the if something is changing, automatically the machine will try to change the pattern, right? Yes, perfect, super.
Yes.
So we started with what is machine learning and why we need a machine learning. Okay, how many learnings? I mean, what are the types of machine learning algorithm we have discussed?
Linear
ML
and
can be,
classification,
sorry.
Supervised learning,
linear,
unsupervised learning,
supervised,
Yes.
unsupervised
supervised
learning,
and unsupervised learning,
Supervised, semi-supervised,
reinforcement
Ah,
learning.
reinforced learning. Right.
very good. Supervised learning, unsupervised learning, semi,
Reinformation.
yeah, reinforcement,
Reinforced.
Yeah.
yes, reinforcement learning. There are 4 types of learnings are available in machine learning. Okay. In which situation or for which scenario we are supposed to adapt supervised learning? What is data set first? How do
these
you
are labeled,
represent the data? How do you represent the data? You have
Labeled
some
data is
data
data.
set.
Labeled data.
labeled data.
Columns.
Very good.
Labeled data we
Labeled
use.
data. The labeled data in general, our focus for the entire module, for the entire session, we will focus only on the structured data only. Structure means number of rows and columns, right? It should be a table. It should be a table. Each and every row can be considered as records. Individual, for example, if it is a patient record 1, patient record 2, patient 3 record, right? Likewise, we can maintain the records. So that is which represents row. And what about the column? Name, patient ID, and age, BP level, right? And for example, BP level and whether they have diabetics or not. Yes. Okay. If you have these many columns, these all are called as features in general. Yes. How many features are there in your data set here?
Five features.
In
5.
total, 5
Right.
features. Whether it is labeled data?
Yes.
Yes.
No,
No.
it's not labeled.
No.
No, no, it's not a label.
Both answers are incorrect. Both answers are incorrect. You should immediately ask, just give me your objective, then I'll tell you whether it is labeled or not. According to my objective and task only, I can check whether it is available or not. Yes?
Agree.
Yeah.
Yeah. If my objective is just check or predict whether the patient will have a diabetics or not. Yes or no. Now, whether it is labeled data for this task.
Yes.
Task 1. Do you have?
Yes.
Yes, I have some data here. In this case, your X will be name, patient ID, age, BP, and then your Y. What is your target? Diabetics prediction. Diabetes prediction. This is task 1, right? Yes. I have one more. Instead of patient name, I have patient ID is we have, right? We can have BMI, body mass index. BMI, right? Now, if my task is just predict the BP level, BP 110 or whatever, right? BP. Is this possible now? Whether just tell me whether your data is labeled data. Do you have input for this?
Yes.
Yes, we have
Yes.
we have column called BP. We can predict it. So in this case, your Y will be BP prediction, and then your X will be BMI, patient ID, age, and then whether they have diabetics or not. This is task 2. Yes, my task 3 is so in this case, these two can be considered as what? Labeled data. Yes. So moving on to the third task. What can I say?
Root cause or genetic disorder?
Stage, okay, fine. Like what is that? Type 1, type 2, right? Some diabetics.
Yeah, type 1, type 2 diabetic.
There are
patients
two
there.
types. Type 1 diabetics and type 2. Sorry. Oh my God. Yeah. Type 2 diabetics, right? If I ask you to group the patients based on the given information, based on whether they are belongs to type 1 category or type 2 category, is it possible? Do you have explicit information?
No.
No. In this case, what I can say, this is unlabeled data, right? Unlabeled data, the entire thing starting from BMI to diabetics value like yes or no, everything, right? Or some you can also, if you want, you can also add some medical parameters here in order to compute this type 1 and type 2, right? Just assume, right? Yes. So all such informations are comes under your X. Your Y will be, we have to group or clustering. We have to cluster into two groups. That is our task. Yes, right. So if your data is labeled data, how do you call this learning?
Supervised.
Supervised learning. If your data is unlabeled data, then it is unsupervised learning. Yes, fine. So based on your target variable, I can perform two different tasks in your supervised learning. For the first scenario, your task is
Labeled.
what is your Y? What is your Y? Yes or no, right?
Yes.
Yes.
Categorical. If your
Yeah.
Y is categorical, then
It is supervised.
Supervised.
Classification.
Classification. Yeah, perfect. Classification. Yes. So what suppose if your Y is real world, real continuous number?
Regression.
Perfect, right? For unsupervised learning, what task we can do it? Because it's unlabeled data. We can do a
Regression.
clustering, not
Sorry,
regression.
Sorry,
Not
clustering.
regression.
Yeah,
It's a clustering.
Yeah.
So in machine learning, for the entire course, our focus is only three different tasks. Either you are going to classify, or either you are going to predict new value, or you are going to group it. That's it. Yes. So based on the Y, I can come up with a conclusion. Okay, I'm going to proceed with a classification algorithm or regression algorithm or a clustering algorithm. That's it, right? If your data is labeled data, then you are supposed to adapt the supervised learning algorithm. If your data is unlabeled data, then you have to adapt unsupervised learning algorithm. Is this clear? Yeah, it's a recap only. It's a recap only, right? Yes. Now, again, I have to introduce the supervised learning in terms of mathematical terminology, right? So what I'm going to do here is, see here, okay, here I have only two variables. One is X and another one is Y. That means it's a two-dimensional data. Yes or no? X and Y. Yes, if your X is tumor size and Y is whether the patient, whether it is a benign case or malignant case. That is what our prediction. Whether it is supervised learning, labeled, whether it is labeled data, first question. Labeled data, yes or no?
Yes.
Y is there. Yes, because my prediction is I need to I need to classify whether the patient is benign case or malignant case, right? Yes, it's a labeled data. Whether it is, if it is a labeled data, how do you say that? We are supposed to use supervised learning. Okay, what is your task? These three are the prerequisite, or you should from the whenever you have a problem statement, you should check these three important information, right? What task I can do it? Very simple, classification. Yes, right. So if See, in the x-axis, I have a tumor size. In the y-axis, I have a classified, different category like benign or malignant, right? So, the both x and xy1, this is called as pair, right? X1 and for this tumor, what suppose if your tumor size is 2 centimeter and it is benign. If it is 10 centimeter, it is malignant. Likewise, you have some pairs, right? XY pair, right? So each and everything is called as data points. Data points. What your machine learning will do here is it will try to, based on the given data like this, for blue is benign and red is malignant after plotting this, right? So based on the given data, the machine will try to learn some function f of x, right? See, it's f of x is nothing but we should pass the x value. Well, x is nothing but your input value to some function. The function will give you some hypothesis. You should see the machine will try to come up with one hypothesis function. If you have passed this input information to this hypothesis function, you will be getting some prediction, right? What is your f of x? What is your f of x? Actual value, right? What is your f of x? This is what your actual value y, and if you are passing the same input to some function, hypothesis function, right? After that you will get some result which is always called as y hat or prediction, right? Model predict this. For example, if for x1 the actual y is benign, right? What suppose if the model predicts benign? What is your observation or conclusion here?
True.
The model correctly predicts the data. For the second patient or for the second record, if your actual y value is benign, but the prediction is malignant, in this case, wrong data, wrongly predicted. Yes. So the thing is, the difference between actual minus prediction can be represented as error term. Will you accept this?
Yeah.
Yes.
Yes, right? See, this is classification. What suppose if you have considered the next example, like I'll tell you in the next example, right? This is what a error. So in the supervised learning, what is the role of machine learning here? What is the role of supervised learning here? The machine will try to identify the pattern behind these data. So how do you identify this? It's just like that. We cannot say that, okay, this is how the data, this is what the trend, right? No, just like that we cannot say that, right? So for that purpose, we should need some mathematical function that can be represented as hypothesis function. For this hypothesis, if you are pausing, right, the model will try to identify the pattern. That is, it's a pure mathematical function. Whenever we started to discuss the algorithm, I will tell you what is the for each and every algorithm, the math behind each and every algorithm will be discussed later, okay? But hypothesis is nothing but it's a mathematical function. If you have passed your input here, then which will provide you the more the nearest value in the sense, for example, if your actual price is $900, right? If your prediction is also $905, right? And this is model 1 predicts this data. For the same input, what suppose if model 2 predicts $1,200, which model behaves best? Which is good? Model 1. How do I know? Because the difference between these two, my actual is 900, predicted is 905. The difference between these two is only $5. But for the model 2, it is $300. $300, right? So if you have more error, the model is not that much good. That is what the conclusion. Is this clear? So our objective is we should reduce as much as possible the error rate. That's it. Okay, this is about supervised learning. That is what provided here. The same. Okay, yes.
And I have one doubt on the previous slide, ma'am.
Yes.
So let us consider the tumor size as 5. So that will belong to both beginner and malignant. So my actual and then predicted result depends upon the error count. Suppose if my actual is malignant and then the predicted is begin means it's a error. So it will be automatically interchangeable because it's lies on same line means how I can able to identify it's a error behavior or it's a normal behavior.
Okay, likewise, you need some quantification here, right?
Yeah.
Yeah. So if your data input data is numbers or a real value number, then you can directly subtract some. You can do this simple subtraction, right? The difference calculation. But here, what suppose if you have 5 datas out of 5, how many records correctly classified? I'll add one more here: malignant, right? So record 1 is correctly classified, record 2 is wrongly classified, record 3 is correctly classified. Out of 3, only 2 records have correctly classified. This is what accuracy here. This is how I can. 1 minus accuracy will be your error.
Yeah.
Okay?
Yeah, okay, ma'am. I got it.
Yeah.
Ma'am, good
So,
morning.
ma'am, can you please explain the hypothesis one time?
Hypothesis. Okay, I'll give you one example for hypothesis. Right?
Ma'am, is it like something confusion matrix?
No, yeah, that is, we will discuss later, confusion matrix. First, we should understand the difference between the how good my model is. For that, you should aware of accuracy part as well as the error part. Okay? It's we should study confusion matrix also. Yes. Okay, let me explain the hypothesis with respect to this. The thing is, see, these all are the classification applications, Google image classification, whether it is a river or a forest area or some other residential area. Likewise, we can using the satellite image, we can do some classification, face recognition system, spam filters, and document tagging. Right? It's okay. The news article says sports, or this is about politics, on this is about business case, likewise, right? And fraud detection also we can do it. These all are the application part, right? And X can be multidimensional, that also you should aware. Okay, it's not necessary that always you should use only X and Y. X can be multidimensional, like tumor size, age of the patient, and BP level. Likewise, you can have some set of X can be multidimensional, that you should aware. Okay, yes. And these all are the different supervised learning algorithm. I'll explain what is hypothesis in the regression topic. Please wait. Okay. We can do a linear regression, logistic regression, naive-Bayes classifier, support vector machine, decision tree, random forest, neural network. This is what, except neural network, rest all other will be covered in your upcoming sessions, modules. Okay, so don't worry. Okay, these all are the different supervised learning algorithms. Okay, and let me explain about the training phase for classification, and then we will discuss about the regression and along with the hypothesis concept, because in the regression it is easy for me to explain the math. Okay. Because since you are in a session 2 only, right, beginner level. Yes. What about this training supervised learning workflow for classification? So initially, just assume if you have 100 records, in general, more oftenly, we will split the data for training purpose and testing purpose. What is training? These topics already we discussed, right? In the last class itself. What is training? Data will be splitted into 2 parts. One is for training and another one is for
Testing.
Testing.
yes, testing.
Train
What is
test split
testing?
model.
What is testing?
Testing is basically
Sorry,
after build
sorry.
up.
What is training? What is training? Sorry.
Training is better the data which is used for the train the model.
Model will try to
Historical data.
learn. Yeah, these all
Historical
are
data.
the, yeah, model will try to, okay, fine, please. Model will try to learn something from the given historical data. In this case, since we are using the labeled data set, both X and associated output should be forwarded, or associate output should be, given to the model for learning purpose. It's like simple, right? If you are going for coaching or tuition, right, they will give you the question as well as answer for learning purpose. Yes.
Yes.
Yes, even in the class also, for learning purpose, if you are going to start study, then the teacher will give you question as well as the corresponding answer. So based on this question answer pattern, you will try to understand, you will try to learn something, and that is what your knowledge level of that particular course, right? Once the model learned such things from the given training data, right, then that model can be called as trained model. Okay, you can ask any question. That is, once you have, see, suppose I have given two questions to you. Once you have studied all those two questions, okay, you can tell that, okay, you can ask any question or ask, I can write a test. No, right? That is what, once you have trained, once your model is trained, I can test you. Okay, for testing purpose, do you want me to share both x comma y?
Only X is
No,
shown.
Only X. Only X should be forwarded or passed to the trained model, that is learned person, right? The question will be forwarded, and then the trained model will give you have to give the answer, right? Which will give you the prediction y hat. Got it? Yes, this is the flow. That is what represented here. So we have a training phase as well as testing phase. In general, we more oftenly splitted the data into 80% for training, because for learning purpose we should give more data. Yes, even though you have 5 units in your course, you will be writing only 5 questions in the examination. Yes or no? Yeah, that is what. For learning, we should provide more content. Then only your model will learn more information. See, what suppose for the entire course, for entire contact session, 16 contact session, if I have given only 3 contact session content, and if I ask you to write the final exam, how much knowledge you have?
For the 3 course.
Very less. Because you know only the very first contact 3 session. What suppose if I ask the question from the contact session 16, that is unknown to you, right? Even you have not trained. Yes. So in that case, your prediction, your answer will be damn sure your answer will be wrong. Yes, same thing is applicable here. So for that is why for learning, for a learning purpose, we have given more amount of data. So hence the scientific split here is 80% of data for records for training, and only for testing you can use 20% of records. Okay, so immediately the features from the data set, the features like x1, x2, x3, x4. Likewise, we will pass some input features for training purpose along with the, what is this? This is x, and along with the target y. Understood? Along with the training label. So the model will try to combine these two, and then it will try to learn the hidden pattern, and finally you will be having the learned model. Now I'm going to assess, or I'm going to evaluate how good this learned model is, right? So for that purpose, I can send one testing image or testing record. Here you should pass only the input feature, no label, there is no y here, right? To the learned model will give you the prediction. Always prediction is, actual data is y, the predicted value can be represented as y hat or prediction. Okay, this is the typical supervised learning workflow for classification. Same thing is applicable for even regression as well. The same flow. Okay, yes. Now, the next discussion is about regression topic. In supervised learning, we have a regression task.
Ma'am, I have a question regarding 80-20% data, right? Yeah.
Yes.
So these 20% data, what we are using for testing should be different from 80% data what we used for the training purpose?
Yes.
Okay.
So if you have, for example, you can randomly, you will do a random split, right? What suppose if you have 1K record, right? If you, in the code snippet itself, if you have given 0.2% for testing, then randomly out of 200 records will be randomly picked for testing, splitted, and 800 record will be here. This is actually unseen data.
Okay.
Because you know about the question, you don't know about the question paper, right? Yes. Yeah, same thing. So this is unseen data that will be forwarded for evaluation. Yes. So the next
Ma'am,
step.
is it fixed? Is it fixed that we have to take
No,
80% and
Again,
20%
no.
only?
Yeah, sorry.
Is it fixed that we have to take 80% and
No.
20% only,
It's
or
not
we can
fixed.
manage?
Yeah, you can manage, but you have to, that is what you have to do a exploration here. So try to fix with 50-50 first, right? How your
Okay,
model
ma'am.
is, if your model is good enough, so it can predict with the help of 50% also. It depends on the data set to data set, right? And again, increase 60-40 or 70-30 or 80-20, right? Even you can give 90% and
Okay.
10%. See, the thing is, out of this, which split is best split? After getting the result like accuracy or error rate, in which split for this data. And one more important thing, especially for machine learning or deep learning, especially in your AI/ML course, whatever course you can study, right? There is no concrete policy for one approach. The thing is, you have to start explore, you have to analyze, because the result will vary from one data set to another data set, because we don't know the pattern behind the data set. It's not necessary that one type of pattern should be applicable, the same pattern should be applicable for another data set also, right? It's very like
Correct,
you
ma'am.
have
Thank
to
you,
do
ma'am.
a exploration for in each and every, whenever you have a new data set, you have to start from the scratch with the domain knowledge. And the next thing is about regression concept, right? What is regression? What, suppose if I ask you to predict the price, house price, right? So here x-axis is year, x-axis is year, and y-axis is like Arctic sea level, sea ice extent, right? So some values are there. What is this blue color points? What is this? What is
Predictions?
this?
Trained data.
No,
Data.
actual data. Actual
Okay.
data. If you have x number of year and ice extent, right? That is what your y will be having some actual data, right? Actual data set, right? That is what plotted here with respect to against each and every year. Is this clear? The blue color?
Yes.
The blue colors
Right,
are
ma'am.
actual data.
Actual
Got it?
data.
Actual data. Okay, fine. I plotted the x and y axis, so that is this is what my information. Okay. What your regression will do here is, that is machine learning will do here is, right? We need to predict, no? We need to predict. What is your prediction?
Red line?
No, leave this red and green line.
Okay.
Leave this red and green line. As of now, you have just passed, you have plotted the x and y axis without regression, without just leave all machine learning concept and all, right? Okay, if I ask you to predict something new, like instead of 190 to 2000, in between, that is 1995. Yes, I need the ice extent value for 1995. In general, what we will do if you have these kind of data alone?
Somewhere between 6 to 7.
Sorry, somewhere around
some value.
6 to 7.
6 to 7, in between.
Yeah.
Yes. So in general, a simple mathematics is, we can take all the values. We will do like y. What is this? Y bar mean or average. Yes. If you don't know anything about with confidence score, right? In general, what we will do, okay, on an average 1995, this would be your y. Yes, so we can directly map our mean value. This is one of the mathematical model, a general model. Yes. Yeah. Yes. What the regression model will do here is, based on the plotted data, it will try to find one best fitted line. This red color is one best fitted line. Okay, this is called as hypothesis 1. What is I told you, right? Hypothesis is a mathematical function, right? So what, suppose if your hypothesis is nothing but y hat or y prediction is equal to, for example, 0.5x plus c. This is line. What is line equation?
AX plus B.
Y
Y
is
is equal to mx plus c. I hope you all remember this line equation. That is what instead of m, I have given 0. Yeah. So m is 0.5 and x is your actual value. I mean input data. Plus I have given some c. C could be anything. Just give me some value, right? For example, 0.8, right? This is what your hypothesis function h1 of x, because this is a line. Using line equation, I have come up with one mathematical model, right? If I passed instead of x, for example, if I have passed input information as for some value in some x value, multiply with 0.5 and add it with 0.8, that would be your y prediction. This is one model. Hope you understood. Yes?
Yes, ma'am.
Yes, this is one model. And what about this green color? Is this a line equation?
Looks like a curve.
Yeah.
Looks like a
It's a
curve,
curve.
right? Looks like a
Ma'am,
curve,
it
right?
looks like values lying in the particular interval, something like that.
No, not it, not like that. Okay, I'll explain this red color line first. Okay, just assume if your x1 of x hypothesis is right, 0.5x, whatever x is passed, you should pass x here, right? Plus 0.8 or 2. What you can come up with any model, right? This is what the best fitted line. Just assume, right? Yes. Now, if my x is 1995, what is your value? What is your equation? 0.5 into 1995 plus 2 plus 2. After simplification, what you will get?
Somewhere around 1000.
Somewhere around 1000. But my y is between 0 to 9. Yes?
Yes.
Yes? Between 0 to 9. This is what? That is what our next discussion. Your data should be normalized. The range should be equal for all column, right? If you have 0 to 10 or 0 to 1, right? So the same scale. See, I can represent a kilogram as, for example, 100 kilogram, right? 70 kg. Likewise, I can represent, and height can be represented using centimeter, 180 centimeter, 195 centimeter, likewise. Whether these two units are same in nature?
No. No.
Is it possible to directly accept this raw data in your equation?
No, ma'am, not possible.
Not possible. Then you will get very, likewise, now we are getting some around 1000, right? Yes, likewise, you will get a different value. But your output should be between these two ranges, 0 to 10. Yes. So what we will do here is these values should be normalized between scale up or scale down, right? 0 to 1 or minus 1 to 1 based on the concept and based on your data set. Either you can keep your entire data from 0 to 1, that is called as scaling. 0 to 1 or minus 1 to plus 1, right? Now, after that, then only you can proceed with the model learning and all, right? For hypothesis equation and all, right? Yes, now you will get some relevant y variable. Okay, this is how. And just assume what, suppose if you are getting, see, actually, if this is, I'll explain how do you get the y prediction in the visual representation instead of this. Okay, yes, if this is what your x 1995, just plot a perpendicular line to your what? Best fitted line. Model learns this line is best fitted line for my given data, right? And then you just plot here. What is this?
6.5.
6.5. For 1995, the value model predicts 6.5 would be the result. Yes? Okay. This is one case. For the same case, if I have used, instead of h1 of x, if I used h2 of x, this is not a straight line, it's a curve. Yes? Just using the second model. Okay, in this case, yeah,
7.
it's exactly 7, right? So how do you assess whether H1 is best or H2 is best? We have to go and check with the actual Y. the difference between y minus 7 and the difference between y minus 6.5. You have to do the difference, and whichever is minimum, that model is the best model. Got it?
Yeah.
Yes. So here it's very simple lining. Don't worry. In the context session 3, we will start discussing about this regression only. Right? I'll explain all mathematical functions and concepts. As of now, just understand what is hypothesis here. So here it's very simple. Y can be what? Hypothesis of x can be some coefficient like 0.5 into x plus 2. This is a line equation. Here it could be 0.5 x squared. It's not a straight line. Yes, it's not a straight line. It's a curve. I hope you all remember for parabola y is equal to x squared. This is what your equation, right?
Yes.
Right, ma'am.
Ah,
Correct.
yeah, that is what.
Yeah.
That is what, right? So what suppose if your x is, I'll give you one input data. You just tell me what would be the best mathematical function, which suits, which mathematical function suits. Okay. Yes. So that you will get clear understanding now here. Yes. If your x is 1, right? 2, 4, 8, okay, one second. 1, 2, I'll keep 1, 2, 3, 4, 5, 6. This is what my x and y value will be 1, 4. Yes. By seeing the input data x and y, what would be your hypothesis of x?
Y is equal to x square.
Y is equal to x square.
Very simple. Y is equal to x squared. This is hypothesis, right? Yes, this is what mathematical function. Are you able to connect the point now? It's very simple data, simple pattern, and I have given very lesser value only so that we can, by seeing the value itself, I can come up with, okay, it's y is equal to x squared because all x values are squaring. That is what my y value, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, right? Likewise, for a complex pattern, you can come up with 2x plus 5x squared plus 6. There is a possibility. Yes? Your hypothesis can be anything. It purely depends on your data and pattern associated with the data. Clear? Yes, that is what our next session discussion, context session 3 discussion, that is regression concept. Okay, I hope now you understood what is hypothesis and all. Yes? It's a mathematical model. Yeah, it's a mathematical model. Depends on the data. We should see. It's manually. It's very difficult for us to understand, but the machine will machine will learn better. Yes.
So, ma'am, quick question. So, from this data set, we derived two hypotheses. Let's say the H1.
No. This is okay. I'll remove this. No. For this data set, right? The first hypothesis is the first and the best hypothesis H1 of x, right?
Yeah.
I can also give the model. It's not necessary that all 60 students should learn everything correctly and all 60 will get 100% mark. Is this possible?
No.
No, your model
ma'am,
can
not
be a
possible.
bias. Your model can be a biased model, right? So what it can do, instead of y is equal to x squared, it can predict like y is equal to 1 plus x. There is a possibility. Yes.
Yeah, but I'm saying
Right,
like
right.
in the image that is there, na? I sextant one. There are two hypotheses that are marked, right? But there could be like n number of hypotheses or like
Yes,
3, 5.
yes.
Okay. So
There are
what is
multiple.
the
There is a 1 second. There is a possibility of multiple hypotheses. That is what each and every hypothesis can be represented as a model 1. This is model 2. Model 1 come up with this result. See here, this is model 1 and model 2, right? Here you will be having model 1 and model 2. Whether the straight line equation is best or the curve line. I mean, it's not a straight line, right? The smooth curve is better. How do I know which model is better? Likewise, I'll take these example to explain here, right? So what suppose if your y prediction, first prediction is what? 1, using y is equal to x squared, your answer will be 4, 9, 16, 25, 36. Yes?
Yeah.
What is your error?
0.
Here 0, here 0, here 0, here 0, here 0, here 0. The sum of all errors will be average.
0.
Even if you have taken average, summation 1 by n, right? All sum of all errors is finally, at last you will be getting 0. Your loss is 0. First model. And the second model prediction? What is your second model prediction?
3, sorry.
1
2.
plus x. 1 plus x. So 1 plus, okay, this will be 2.
2.
Yes,
2.
this will be 3. This will be
3.
4.
4.
I'm just incrementing the number one by one, right?
5.
5, 6, 7.
6 and
The
7.
error is difference
Plus
between
1.
plus 1. Okay, you can take absolute. That's just a difference. Okay, 1.
1.
Error is 1. Here, the error is 1. Here, error is 5. Here, error is
9.
9.
19.
No. 9 plus 5? No.
Not 9, 11.
11.
11.
11. It should be
Okay.
11.
Yeah.
Yeah, it should be 11. It should be 11. Here, it should be
19.
19.
19.
29.
20.
29. 9.
29. Add all together. That is your total error divided by 6. That is your average error for the entire data. See, first model, if you are using this hypothesis, for example, just try to connect. This is your first model and this curve is your second model, or either vice versa. Okay. Which model will you proceed? Again, whenever you have a data, you have to proceed with lots and lots of exploration. Then only you can come up with the final conclusion. That is your trained model. You can conclude that, okay, this is what my final trained model. Now you can start evaluation. As an analysis, it's your responsibility. You have to conclude, okay, this would be the best and final model, learned model. Okay. Shall I proceed?
Yeah.
Yeah.
Ma'am,
And
one small doubt, ma'am.
yes, please.
Yeah, let us consider your two models. Could you please go to the previous slide? So my model 1 will give the proper answer for 1970 to 2000. And my model 2 will give the proper expected result for 2000 to 2020. So if in this case, can I consider two model as a successful model, or I need to go another one more model?
No. That is what. Yeah. The thing is, see, if both models are not providing a promising result, that is for each and every domain, there should be some benchmark, right? Yes.
Yeah.
Yeah. So at least some like pass criteria for writing test, a student must get 50%. Then only they will declare that particular student got passed in that particular subject. Yes. Likewise, for each and every model, we should have some threshold, the benchmark or baseline model. Okay. So at least your model should give 80%. What suppose if both models are there is a possibility in real time, both hypotheses can lead you to reach a maximum error. In that case, you have to retrain. You have to retrain again and again until you reach a best promising result.
Okay.
Yes. See, how do you, okay, you can have one question. That is what in the next context session only, your all questions will be answered, because you can ask like, okay, model 1 is not good. Model 2 is also not good. How do I know which model, the third model? Because these three equations, right? So you have to do some hyperparameter tuning. In each and every model, there will be some weights or there will be some coefficient value. I'll give you one example here to introduce that. Okay, for a house price, this is what your Y value, price of house. Square feet, I have a square feet plus whether it is residential area or not. And I have some bias value, that is constant value. So see here, okay? Yes. So for each and every value, there should be some coefficient. What is this coefficient? This coefficient will tell you how good this parameter is or how much important this parameter is in order to predict my Y value, right? Just tell me, it's a domain understanding, right? Whether square feet is comparatively, we have to provide higher importance than residential, or residential we have to provide higher importance.
Square feet.
Square
Square
feet.
feet matters.
Residential.
Yeah,
Residentials.
No. Square feet matters. Budget. We are talking about budget. Yes, we know. See, we always expect the house in nearby city or in the residential area because of my lack of budget. What we will do? Okay, I can instead of city area, I can go after 20 kilometers. I mean, in the urban area. Likewise, we will take some decision, right? The price. How? See, now you just tell me which parameter is more important parameter in order to which is deciding authority here? Square feet.
Square feet.
Right, compared to residential. No, I'm not saying that residential is very we should give less weightage on and all, right? We have to give weightage for residential, but compared to square feet scores first rank. Yes. So how do you represent this? I can give 70% importance for square feet, yes, or 60% importance for square feet plus 30% importance for residential area plus 1% importance for any, is there any other like community or whatever, okay, plus some constant value too. Here you will be having some 0.6, 0.3, 0.1, right? What suppose if your first model provides this much importance, if you have very low error, or if you have very high error, right, then the model will try to adjust these parameters by automatically. Understood? Are you able to get my point? Everything is dynamically updated within the model itself, right? Then only you will get one final conclusion. After that also we have to fine tune the parameter. There are each and every algorithm has some parameters, like in the mathematics you have studied some rho, lambda. Likewise you have studied some terminologies, right? I'll tell you what is that. Correct, exactly here. Yes, what is that? Like each and every parameters here, the roles and responsibility, right? How this particular parameter controls, which scenario we are supposed to increase the lambda, in which scenario we are supposed to decrease the lambda. If I increased, how my model will behave. That is what our next discussion. Okay, shall I proceed?
Yes, ma'am.
Yes, we are in only 15th slide. Okay, don't interrupt for 15 minutes. Okay. Otherwise I'll mute everyone. Okay, fine. The next thing is unsupervised learning. I hope you all aware unsupervised is it's unlabeled data, right? Based on the unlabeled data. See here, based on the similarity, I can club the, I can group the data, right? So here, how many groups I can do it? Possibilities are red group, green, blue, yeah, and yellow. These four are the groups, right? And even see, this is about unsupervised learning. One task is you can cluster. And what about this one? Yeah, what about this one? People that buy X tend to buy Y. In the supermarket,
Association.
Association. Whenever we go for supermarket, right? Alongside of bread counter, they will usually in the previous case, we have a jam or butter. Likewise, right? Now you have a sandwich spread. What is that? Some sauces. Likewise, you have so many mayonnaise. Likewise, we have so many stuffs nowadays, right? So everything will be arranged in a nearby counter itself. Yes. What is the purpose? They analyzed if the people, those who have purchased the bread, they always tend to purchase these many products. So that is called association. All such tasks can be performed using unsupervised learning. Okay, so this is what unsupervised learning representation. Initially, I don't know what is each and every data is. After finding the similarity between this and this, this and this, this and this, this and this, I'll see the mission will try to find out the similarity between each and every data point too with respect to all other data points, right?
Data points.
Yeah, I'll give you one conclusion here. If the distance is high, similarity is
Less.
low.
No.
See, with respect to this data point and this data point, if you have computed the distance, straight line equation, Euclidean distance equation, right? The distance between these two data points are high in nature, yes, compared to these 2 points. Yes or no?
Yes.
Yes,
Yes,
ma'am, it is
right?
noticeable.
Yeah, if the distance is high, this how similar these two are.
But there is a possibility like a similar product can be nearby as well, right?
Similar.
Yeah, that is what the similar products, that is what using the distance and similarity can be calculated using a math. That is what, see, we can say that, okay, how similar, how resemblance one data point or one person to another person by seeing, we can by identifying the extracting the features, facial features, something, we can conclude that, okay, both are looks similar, both products or both persons are look similar, right? But in how the machine will do it, everything we need a mathematics, right? So what it will do, it will use some distance measure or the similarity measure. We will discuss, okay? Don't worry. Distance measure or similarity measure, based on that, it will try to group together. Okay, these four can be one group, or these four can be one group, and these four can be another group. That is called as unsupervised learning. These are the applications: personalized recommendation system and target marketing. Like in supermarket, we did right. I mean, they did right, and spam filters and content management, and we can see there are lots, and in all domains we can use the especially in business, unsupervised learning. These many algorithms are there. K means clustering, hierarchical cluster analysis, and expectation maximization. Okay, and we have some other subtopics also, how to reduce the dimensionality and using the principal component analysis. Don't worry, all our technical jargons I know, right? Whenever we reach to that module, I'll start from the scratch. Like I'll introduce the math, and then I'll introduce the context. I will introduce visually how to interpret such algorithm, and then only I'll proceed with the numerical, so that it's a package, right? So math, then visual representation, geometrical representation, and then context, and then only I'll explain the numerical, so that it will be easy for you to understand each and every algorithm. Okay. Yes, and this is a typical unsupervised learning workflow. We have to provide the input unlabeled data. Feature will be extracted. Only the feature will be extracted from the data and any machine learning algorithm, and it will form a group. Like, okay, these three are similar, features are similar, so it can be one group, and these three can be another group. Okay, and what about reinforcement learning?
Agent-based learning
Yeah, it's a
environment is there.
agent-based learning environment. It's
Based on
actually,
the
it's not an
feedback.
agent, it's a feedback-based learning, machine learning technique. Okay, it's very simple. Feedback can be reward or penalty. Yes, feedback can be reward or penalty. If the agent,
Penalty.
yeah, if the agent does a proper thing, see here. Okay, yeah, this is the best example. The entire thing can be considered as an environment. With the help of sensor, the agent will sense the input, perceive the input from the environment. The inputs are, okay, there is a flame here, and there is a water here, and even we can say that, like, see, it will first observe the environment. Okay, it will first it will observe the environment, and there are two possible action the agent can perform. Either it can go to the near flame or here, right? Select the action using some policy. The policy says, based on the past previous experience, the policy will suggest the action. That is what action, right? If you are new to the environment, the agent will start exploring, right? Yes. So what, suppose if the agent selects this action, what will happen?
Penalty.
Agent will be warned.
Penalty.
Yeah, obviously the agent will get a reward or penalty. It's a bad
Penalty.
action. Yeah, it's a
Penalty.
bad
Penalty.
action. Obviously, agent will get a
Yes.
Depends
penalty.
upon the rule on
Yeah,
which
yeah,
policy
Action
it
not
has been
supposed to be
designed.
there.
yeah.
If it is designed to fund the heat, it will be getting the reward. If it will be
Okay. No,
designed for the
it's general.
sole
It's a general approach. Instead of thinking like agent, you just think like a kid.
That's where I have this confusion. Like in real world, we can punish or reward a people, but how we can punish or reward a model exactly? Do we give them a point, or
Yes.
would they perform?
Yes.
I
Yes.
guess it's depend on objective, right?
Objective. See, it depends on the objective. What suppose if this is not my objective, right? The agent, in this environment, the objective is the agent should close the tap or it should move the bucket near to the tap. That is the objective. That is what we expect, right? As a agent, if the agent is unknown, I mean, if the environment is unknown, initially, if nothing is stored into the memory of the agent, so the agent, what will do? It will randomly select any one of the action. What suppose, unfortunately, if agent picks this action, obviously it will get some penalty. What is this penalty? There is some architecture in order to maintain the penalty and reward in artificial intelligence. Do you have ACI course parallelly? I hope you have, right? Artificial.
No, ma'am, we don't have.
No, ma'am.
No, no.
We have
in the next
ANN.
term.
We don't have ACI.
Okay, you are in second semester right now. Or you? No.
First semester.
Oh, yeah.
Ma'am,
Sorry,
first
my
semester.
bad.
This is
It's
first
my bad.
semester.
Yeah, it's my bad. Like,
Ma'am, sometimes I get confused
no,
about the
no.
semesters.
You should
I
not
think-
confuse it because I have taken different sections and so I can't.
I think
But ma'am, we are in first semester, but
Academic semester.
everywhere it's a
But
second
it
semester,
shows second
25.
semester.
Actually, as per the year calendar, it is a second semester, but
Yes,
is a
as
first
per
calendar.
because you are S225, right? Second batch.
Correct.
According
Yes,
to
yes.
your enrollment, you are in first semester, but for us it's S225.
Class.
Okay. So that is what. See, it depends. There is some architecture. Maybe in the next semester you will be having the ACI course. There you can they will discuss the detailed agent architecture and all. Don't worry, right? So the how the penalty and how the rewards will be stored. There is some architecture to store such information. Based on that accumulated penalty and reward, the agent will come up with one policy. Okay, I should not take this action. I'll always, if I see, it's very simple. If the kid, like I mean, like for a first standard or second standard kid, for what suppose if he or she earned 8 out of 10, 8 out of 10 or 6 out of 10, if the teacher gives 6 chocolate, what the kid will do the next time?
Tries to get
Tries to score
If the
more.
chocolate is
Oh,
good,
yeah, the
it
kid will try to score more, right? 8 out of 10. Again, for what suppose if the teacher gives like 8 chocolates, then 10 out of 10, right? Then it's 10 chocolates. All such are called as rewards, right? So what could be the penalty in this environment? 4 marks lost. 4 times imposition.
4 chocolates lost.
4 chocolates lost.
Like a penalty and reward system, all such information should be stored. Even see, this is for human, we know that, okay, for 10 out of 10, what suppose if the kid act like this? See, out of 10, I mean, out of 12 questions, the student should answer 10 questions. So hence, she will get 10 out of 10 or he will get 10 out of 10, right? If what suppose if the kid wants to get more chocolate, okay, I can write 12 questions, right? I can write 12 questions and all 12 questions are correct. Whether the teacher will give 12 chocolates here?
No.
No way. It's extra question. It's an extra question, right? So in such a way that you should design your agent intelligently, right? It should not overact. It should not underact. It's like overestimation, underestimation is not applicable here. Yes. So it should, that is what. It's totally different chapter. You will be studying next semester in ACI course. It's very, very interesting course. Okay. Yes. And these all are the types of learning as a summary chart. Okay. Initially, we have machine learning. 4 types: supervised, unsupervised, semi-supervised, and reinforcement learning. If your target is continuous, you'll do a regression task. If your target is categorical, it is a classification. Examples are there. And if target is not at all available, then you can do a clustering or association. Customer segmentation or market basket analysis is the example for unsupervised. Semi-supervised is nothing but if you have 10K data, right? For example, 6K data can have labeled data and rest of the 4Ks will be unlabeled data. In that case, either again depends on the target, you can proceed further, right? Reinforcement is, it could be a categorical target variable, and there is a possibility. You can have categorical target or no target variable at all. Then you can do a classification and all. This is the simple summary chart of different types of learning, and these all are the comparison. That is what we discussed so far. Okay. And so I'll stop here. Yes, I'll stop here.
Ma'am, I have a question, ma'am.
Yes.
Ma'am, the different types of machine learning that you were showing, right? So to solve a particular problem, can we do a mix of all these 4 types of learning?
No, no way. It's clearly stated that, yes,
Okay.
first you should go and check your data set, whether the data consists of both X and Y or not. If both X and Y are there, it should be directed to supervised. If you have only X, then it should be directed to unsupervised. Got it? This is first category. And from here, okay, if you have X comma Y, with respect to X, if it is a continuous numerical number, then you have to proceed with regression task.
Regression.
If it,
Okay.
yeah, it's a constraint based process.
Okay.
Yeah, we cannot combine multiple algorithms. Not algorithm, multiple. See, with respect to supervised, you can do a ensemble learning. That is, you can combine multiple algorithm and then you can come up with the best result. That is totally different. Okay, but you cannot mix up with supervised plus unsupervised or unsupervised plus reinforcement. Each and every learning is totally different.
So, ma'am, we should rely on the data set plus objective to choose
yes,
like a particular type of learning,
okay.
right?
For learning, you should check the data. For learning, to select the learning, you should check the data. To select the task, you should check the target variable or objective. Okay.
Yes, ma'am. Thank you.
Yeah. Okay. You just take 5 minutes of break and then I'll proceed with the as per today's agenda. 11:30, 11:40.
Only one question regarding unsupervised learning.
Yes.
Am I audible? Yeah.
Yes,
In
yes,
unsupervised learning, we are clustering, right? So then, let's say, for example, you shown the dog and cat classification, right? So it's able to cluster. Then, then how it will be named? Let's say this is dog, this is cat. How that naming?
No. We cannot name it. Like that is what we can see. The
It's
thing
only
is,
for clustering.
no. It will try to cluster, but based on the again the objective in the problem statement itself, you can come up with you can map the labels after that, after grouping. Because in your problem statement, you will be having some, okay, this much, I mean, the eye should be like this, or some description will be there, right? So based on that only you will identify the similarities. After that, you can conclude that, okay, this could be the cat and this could be the dog.
Yeah, is there any manual intervention required? That is my
no need.
Okay, so let's say we say these are the group of what is that pictures? For example, these are the group of pictures available. Like one group is cat and another group is dog. So these are the features of cat and
it's not like that. No, it's not like that. See, it's not explicitly provided, first of all. In the problem statement, they have given a detailed description or detailed features of each and every image. Okay. For that, using the detailed description and feature, you have to extract the most important feature, like eyes or the height or the breadth of the animal. Likewise, you should have, you can come up with the best feature extraction. Then only the model will group into two categories. Okay. There is a possibility here one dog will be there or here one cat will be there. There is a noise, right? There will be a noise. But after grouping it, you should okay, if it is a medical data, or if it is like this, if the real world data set, we can use the domain expert to name it, if it is not explicitly provided. That is what your question, right?
Yeah, like after
If
clustering, like what is the
after
application of
clustering, after clustering, if in the problem statement itself it is clear, if it is explicitly provided, you can name it. It's very simple. Yes, based on the feature. Otherwise, you should take a domain expert. If you don't know, if you know for sure about that task, you should take help from domain expert.
Okay. So here the job of machine learning is only to cluster, like
Group, cluster,
group.
cluster. Yes.
Okay.
Okay, 5 minutes
Yeah,
break.
thank you.
Ma'am, 1 minute only. So, does reinforcement learning also use mathematical formulas to find out pattern, like unsupervised, supervised?
Yes. There
So
is some
reinforcement.
yeah, in reinforce. See, without maths, we cannot study any subject hereafter, especially in AI ML. In each and every algorithm, there is one algorithm called Q learning algorithm. That is the basic model, basic algorithm. There will be some equation to represent the real world scenario, how the reward is calculated, how do you calculate the penalty, right? For each and every iteration, for each and every action, we should calculate it, right? It's a calculation part, right? Again, we need to take help from maths.
Okay, and are we going to cover that as well?
No, no. Our only focus is supervised and unsupervised.
Okay, so if I have to take reference, then any
Yeah, that is what
suggestion
in the
from?
upcoming semester you will be having a reinforcement concept, and the agent architectures are there, right? Different agent architectures are there.
Okay,
With
ma'am.
respect to scope of the course, our focus is only labeled data, unlabeled data, supervised and unsupervised learning.
Okay, ma'am.
Okay.
Hello, ma'am. I have a doubt. Uh,
Shall we proceed?
Yes, ma'am.
Yes, ma'am.
So the next discussion is about ML workflow. Okay. So these all are the process. Like, see, first, whenever you have a problem statement, you should, as an analyst, data analyst or machine learning engineer, you should check or analyze whether the problem statement needs an ML related solution or not. Should I use ML on this problem? Is it possible or is it applicable or not? Okay. Is there a pattern to detect? Right? Can I solve it analytically or do I have a data? So all such question you have to ask, and once everything is yes, then you should start gathering and collecting and organizing the data, pre-process the data, clean the data, visualize the data. This is all are called as exploratory data analysis. See, because one project can deal with medical related data, medical related image data, or another project can deal with business related, e-commerce related data set. So whenever the problem statement, the entire context and concept will vary from one data set to another data set. It purely depends on the domain, right? So you should start from the pre-processing, cleaning. You should understand what is there in the data set. So that is called as exploratory data analysis. After choosing the appropriate model and loss regularization, you have to do a optimization, finally do a hyperparameter tuning and analyze the performance and mistakes. Iterate back to step 5 to 5 to 3, right? 5 or 3. Even you can start with what, suppose if you have not done your pre-processing properly, then now obviously you will end up with the, if your data is not that much good, you have to prepare your data for model, for training, right? So if your data, you have to start from the third step or fifth step. It depends on the problem statement and data, whatever data you have in your hand, right? So the next discussion is about, it's a car price prediction based on mileage, right? In how many features are there? 4.
One.
1, 2, no. 3, like 2.
2.
2 or 3.
Ma'am, mileage price.
Mileage and car price is there.
Ah, what is this
Actual.
H naught? This is hypothesis function. Only
Yes,
one
yes.
input, only
So
one input
mileage and car
feature.
price, two are there.
Yes.
Two are
Not
there.
2. Actually, features means always it is
Only one
associated with the input.
Okay.
Okay.
Okay,
Target
ma'am.
or label means Y. Okay. Only one feature is there, and obviously you'll be having one target variable only, right? And X is mileage and Y is a car price. Based on my hypothesis, some equation, some mathematical equation, just assume, right? I have 9, 8, 9, 9. And what is your error for this with respect to model 1, last one?
It's
Actual is 10 minus 9. You will be getting, or you can round off, it's 11 or whatever. Okay, something, the error is 2, and here the error is 1. I'm just round off the value here, right? And 6.95 minus 9, it could be 3 or 2. Likewise, you'll be having some error, right? For calculation purpose, I have taken the numbers, but it should be a appropriate value, correct appropriate value, right? And so here, what is just define the objective here. What would be the objective?
car price.
Predict the car
price.
price.
Yeah, data. See,
Yeah.
it's a we need to gather. See, these information can be these information can be gathered or collected based on some survey or past purchase data, right? What is your data pre-processing? We have to split the data for training set and test set, and then representation of input feature and output feature. You should aware first what would be considered as an input and what would be considered as an output and all, right? And do the exploratory analysis, choose a formal of model, like this is linear regression, right? First of all, your Y is continuous numerical. Obviously, we are supposed to adapt regression, but you don't know what type of regression I'm supposed to use. Just assume it's a regression task. And system performance evaluation, come up with the objective function, whether I need to minimize the loss. What is this parallel class?
Someone is playing the recording or
Yeah.
put it everyone.
No, actually, government alert is there to whole India. They have like created something to inform everyone. So it is trial alert.
Oh,
That was at 11:42.
No, it just happened now in Hyderabad as well. Just
Yeah,
happened.
it
just happened in Hyderabad.
In
okay.
Delhi, it was at 11:42.
Okay, fine. Yes, and then optimize it. See, these all are the steps which we are going to discuss in the upcoming algorithms. So don't worry, right? This is the flow. And so as per today's plan, like actually context session 2 starts from here. Role of data. What is data first? Role of data, and then data pre-processing and data skewness and removal and model training. Yes, these I'm not sure whether I can cover these three. Right, let me start with first one. So ML in a nutshell, like see, it's very simple. Tens of thousands of machine learning algorithms are there. Like, see, even there are a lot of algorithms because your data is huge, larger in nature nowadays. Every ML algorithm has three important components. One is data representation, parameter optimization, and model evaluation, and the best model selection, right? So first understand the domain. You should have some prior knowledge and goals, right? Then integrate the data, select the more appropriate model, clean the data, pre-processing, learn optimal parameter, interpret the result. If you are not able to if you are not able to reach the promising value, then do the same process again and again until you reaches the optimized final result, right? Consolidate and deploy in the either you can deploy the project in cloud platform or whatever. It's your wish, right? This is it's a ML in practice. Now, what is data?
Information.
It's a collection.
Generally,
See,
raw fact
data.
and figures and fuel
Yeah,
in data science.
yeah. There are multiple types of. There are, different types of data are available, right? We will start discussing with one by one. Okay, data is nothing but it's a collection of data objects and their attributes. What is object? Each and individual record can be considered as an objects. Yes, this is first record can be an object, second record can be an object. And what about attributes? Attributes are the column names, refund, marital TID, marital status, taxable income, whether they cheated or not, right? So all such informations, the data object means one complete record or one entity is data object. Okay, it's simple. Okay, in the table, one row is object, data object. And what is our attribute? A column name, a characteristics of an object, right? Character, for example, if you have a flat, right? You can have some characteristics. How many square feet, whether do you have a car parking
Height,
or not?
width, volume, etc.
Yeah, likewise, it's a house, one flat. You have one flat, right? Whether it is a resident, it is located in residential area or not. Likewise, you will be having some features, right? Characteristics of flat. So all such informations are called as attributes. Okay. So eye color of a person, temperatures. There are multiple, right? And collection of attributes describes an object. Is this clear? Are you aware of object versus attribute? It's very simple. A single
Yes,
row
ma'am.
is called as object, and each and characteristics of each and every object is called as attributes. Okay, we have different types of attributes. One is nominal attribute, ordinal, interval, and ratio. What is nominal? Nominal means used for names or labels. There is no order, right? If no order
General
is
text data, we can say.
general, yeah. So for example, ID number, zip codes, can we arrange it as per the larger value and lower value? No, right? The zip codes, right? Gender, is it possible to can we say that male is greater than female or female is greater than male? Is it possible to compare these two? No, directly no, right?
Yeah.
And the blood group, for example, if you have A plus, O plus, O negative, O positive. Likewise, if you have, is it possible to tell that, okay, A plus blood group is greater than A negative? No way, right? Yes. So all such, see, the only thing is, these all such attributes are called as nominal attributes. Is this clear? There is no
Yes,
order
ma'am.
associated with that. What about ordinal?
Yes.
There is an order is associated in this data set, right? Attribute like ranking, for example. You can also provide some reviews, right? For a movie review,
Like
5
chess
star,
number of a
5 star,
cricketer.
5 star, 3 star, 2 star, 1 star. Is it possible to arrange?
Yes.
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 I know
It
that
could be easy.
one
Yes,
is,
yes.
one is lesser than 5 star. I can compare, right? There is order, there is an order. Yes, even is it possible to arrange whether, okay, I'll give you small, medium, large, XL, double XL. Whether it is ordinal or nominal.
Ordinal.
Ordinal.
We can arrange it, right?
Ordinal.
Yeah, there is
Ma'am,
an
if
order.
if
Yeah.
attributes as a category, then we can say it is a ordinal, right?
Simple categorical. So sorry, in category, if you are able to do some orders, like
No, what I'm saying, if attribute has some category, right, then we can say it is a ordinal, right?
yes.
Ordinal attribute.
No. Yeah. See, ordinal is nothing but the feature should be categorical. That is mandatory. Even for nominal also, we can have a category like yes or no, male or female, right? When, see, ordinal attributes used when values have meaningful order or ranking.
So can you say comparison, ma'am?
Like review writing.
I think what ma'am is trying to tell is that in ordinal, the values are relative to other, but nominal
We
it
can
is sort
compare.
of, yeah, sort of that.
Yeah, see, I have some, for example, one column called gender, male, female, likewise, right? And another column called a t-shirt size, small, XL, double XL, medium, right? So if you have, is it possible to rank it male and female? Is it possible to rank?
No.
No, that is nominal. Okay. But here I can rank it either smaller value to smaller value can start from 1 and larger value can likewise, right? How do you map it? How do you map it? Small size should be 1, medium size should be 2, this XL should be 3, and double XL should be 4. Are you able to get my point now?
Yes, ma'am.
Yeah,
Right.
Even tall, medium, short. This goes to first rank, second rank, third rank. Or if you want to provide priority for tall, then keep it 1, 2, 3. It's your wish. Yes?
Yes, ma'am.
The grades, A grade, O grade, B grade, C grade, all are comes under ordinal. And what about interval category, interval? See, such kind of used when values have a meaningful difference. But here we cannot find the meaningful difference. Yes, but in the ordinal data, we can have meaningful order, but there is no meaningful difference. Yes or no? But in the interval, you can have meaningful difference, right? But there is no true 0 point that you should remember. For example, temperature in Celsius or Fahrenheit or calendar dates from here to after 1 week. Likewise, you can have some interval. You can calculate the intervals. And what is the ratio? If the values have a true 0 point, no comparison using ratio is meaningful. So see, so comparison using ratio is meaningful, right? So the temperature in Kelvin, length, count, elapsed time, time to run a race. Likewise, you can have some ratios. So these all are different types of attributes. Whenever we are dealing with the different data sets, I'll explain what I'll ask you to like,
Excuse
what
me,
can I
ma'am.
say? Yes.
I have confusion in
Temperature
interval
in
and ratio.
Kelvin is in ratio, while the temperature in Celsius and Fahrenheit are considered to be in interval.
Sorry?
How?
Sorry?
I mean, the last slide, you have shared the examples. Yeah, temperatures in Celsius or Fahrenheit, it is put under interval, right? But in case of ratio, you are giving the example for temperature in Kelvin. Like, on what
Same
basis we are
confusion.
categorizing it?
Interval and ratio.
Okay, I'll give you one example. You want to compare interval versus ratio, right?
Yes, ma'am.
Question is on Kelvin. Kelvin has an absolute zero. Celsius and Fahrenheit are measured based on Kelvin.
Yes.
So So basically, it's like count of girls and boys in a class, right? You can have a difference and can come to zero, something like that.
Yes.
Versus even though you consider January to December in numbers, right? 0 to 12 or whatnot, but you cannot differentiate two and come to
Yes.
zero, right? Zero
Yes.
is January, right? It's not like the absolute zero value. It
Yeah,
exists.
it's not absolute. See, zero is not absolute in interval. See, the thing is you have interval as well as, for example, ratio. These two, right? The formal definition for interval or the meaning is values have equal intervals here. Values should have equal intervals, but here values have equal intervals. Here also values have equal intervals, but true zero also acceptable. True zero is also acceptable, right? The thing is, zero value, zero is not absolute here. Zero means absence of quantity here. Here, zero means absence. Zero tells the absence of quantity. See, a comparison, ratio comparison is like here it's not meaningful. We cannot compare the ratio here in the interval. We cannot do it. But here it's meaningful. It's like, for example,
Or
20
can we
degrees,
consider it?
20 degrees Celsius and 40 degrees Celsius. This is temperature, right? Yes. For interval example, how do you say that 40 degree is like 20 degrees Celsius hotter than 20 degrees Celsius? Yes or no? The difference.
Yes.
How do you say 40 degrees Celsius? 40 degrees Celsius is 20 degrees Celsius hotter than actual 20 degree Celsius. Yes?
You perfect.
Yeah. But we cannot say 40 degrees Celsius is twice as hot as 20.
Correct.
Because 0 degree does not mean no temperature. That is not at all possible. Yes. But in the ratio, what suppose if you have weight as like 20 kg and 40 kg, 40 kg and 20 kg weight, we can say that 40 kg is 20 kg more than 20 kg. That is fine. And also we can say that 40 kg is twice of 20 kg. Because we accept zero here. What is the representation of zero here? There is no weight. We cannot say that in this example there is no temperature. See, simple memory trick here is like what you can say, like how do you remember this? Interval means difference is meaningful. Here the difference is meaningful. Ratio is difference. Along with the difference, even the multiplication or division or power, it's meaningful. That is also meaningful here. Why? Because we consider the ratio considers zero, absolute zero. Absolute zero means the absence of the particular quantity. Okay. Yes. The next thing is we have two types of attributes. One is discrete attribute and another one is continuous attribute. See, it has only a finite or countable infinite set of values. For example, zip codes. If you have 1,000 cities, you will be having 1,000 zip codes. And or the set of words in a collection of document, the countable, right? So all, if you are able to count it, then it is called as discrete attributes. What is continuous? It has real numbers. It's not a finite numbers. It's a real number as an attribute value. For example, temperature, height, weight. For example, I'll take height alone, right? There is a possibility. Just assume always for adult height starts from 135 centimeter to, for example, 180 centimeter. Just assume. In between, there will be multiple values. Yes or no? Is it possible to count?
No.
It's not possible.
No, because 135.1, 135.2. This is sample. You can also 10 something, right? You can also have some values, right? So it's not a continuous real numbers as an attribute value. Then it is called as continuous attribute. Practically, actually, real values can only be measured and represented using a finite number of digits here. So for better understanding, continuous means floating point values or variables. Yeah. So the important characteristics of data are the dimensionality. If you have a number of, if you have four attributes like, for example, square feet, the residential or not, car parking is there or not, or crime rate. Likewise, if you have these many columns, as well as along with that one label data or target data like price, right? So the dimension can be represented as this data set is 4-dimensional data, right? High dimensional data brings a number of challenges. If your number of dimensions, number of columns are increasing in nature, then such data sets are called as high dimensional data set. Is this clear?
Yes, ma'am.
Yes. Yeah. What is sparsity? Another terminology is sparsity here. Only the presence count is called as sparsity. What like a sparsity, the sparse versus dense vector. The thing is, I hope you all aware of matrix, right? How do you represent 4x4 matrix?
4 rows, 4 columns.
4 rows?
4 rows, 4 columns.
4 rows, 4 columns. So 1, 2, 3, 4. Yes. 1, 2, 3, 4. If I have given 1, 1, 1, 1, rest all others are 0.
Sparse.
It's sparse.
16 values should be there.
Yeah. Yeah. This is 4x4 matrix, right? And this matrix representation, you see, only available data are the enabled values are 1, 2, 3, 4. Rest all other values are 0. This kind of matrix or representations are called as sparse matrix or sparsity. Are you able to connect the dot now? Sparsity. And
Ma'am, is it when most values are 0 or
most values? Yes. Most values should be 0, right? So here 1, 0, 1, 2, 3, 4, 0, 5, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Now it's a dense matrix because lesser zeros. Okay. And dimensionality is nothing but the number of columns or number of features, and sparsity is nothing but the presence of values, presence and absence of values. And the third one is resolution. Resolution is pattern depends on the scale. What is resolution in this case?
Four by four and
Sorry, like how do you represent one image data?
pixel?
Pixels. How many
Resolution.
pixels? Yeah.
It's a resolution, right? So one image or one JPEG or PNG file can be 255 cross 255. Yes?
Two-dimensional, right?
Yeah. It's a 2-dimensional. Just assume it's a 2-dimensional. That is, the matrix values are nothing but 255 cross 255. This is how the pixel value. This is how the pixel value can be represented here. Okay. That is called as the resolution can be represented here. Okay. Level of level of detail or scale used to view the data. Okay. So the scaled data can be analyzed daily or monthly or yearly. Each scale may show a different pattern. This is what resolution. With respect to image, you can use this kind of matrix. What suppose if you have a numerical data or weather report, if you want to analyze the weather report, you can analyze the pattern yearly. Yes. It's a generalized pattern. Yes or no? Yearly wise, you can in each and every year or once in a year or twice in a year. Likewise, you can do some kind of analysis. Yes or no?
Yes, ma'am. But one question is like with these characteristics, right? So will there be any formula how we will be utilizing these data?
No, that will be because it's an introduction. I'll talk about the dimensionality reduction so that you can connect what is dimensionality there. The sparsity also, like in the image, whenever we have an image data set or vector representation or matrix representation, if I have if I want to communicate like, okay, it's a dense matrix or it's a sparse matrix, you should aware of sparsity. And image data, it's resolution. When we talk about the resolution point of content, then you should aware of resolution. Even in the trend analysis, like stock market prediction or the fall or profit, right? So you can analyze daily basis. You can analyze hourly basis. Yes, specific. How specific? Yeah, I mean, you are in that particular domain. That is what. How much clarity you need for a given problem statement, like it's a daily basis or hourly basis. It depends on the objective and problem statement, right? Whatever we discussed in the first two context session, everything will be reiterated in the upcoming session.
Ma'am, one question on this. This data, the type first two is okay, but when we talk about the third, which is resolution, we are only talking about data of picture type.
No.
Like,
This is first category. Image can be represented using matrix. What suppose if you have a structured data like this, stock market price prediction or something, or weather prediction? Yes, if you are going
can we
to
equate this resolution with the samples? Like if I want to use some daily or hourly or
yes, that's it.
seconds
For a same problem
or
statement can
something
be
like that.
analyzed yearly basis, daily basis, hourly basis, weekly basis, right? How specific you are. Based on that, you can get a more clear understanding, right? The resolution refers to a level of detail or scale used to view the data. Okay.
Okay.
Yeah. So the size is nothing but the amount of the shape, total count, right? If you want to, if you, in your data set, if you have 10,000 records, then the size should be 10,000 records. Okay. So it's 12:15. Okay. I can proceed with some more slides also. Yes. There are different data types. These many data types are there. Relational object, transactional data, document data, web and social network data, spatial data, time series data, and sequence data. Okay. It's very simple. It's easy to understand. I'll explain in a shorter way, right? What is relational means? Data stored in a table format, because I hope you're all aware relational database management system, SQL, it's a structured query, right? Structured query language, right? So your input should be in a arranged in a row and column or table format. Yes, with rows and columns, all such data are called as relational or object. What is object? Each and every record can be called as object. Okay, here the records, a first record deals with Jack, and second record deals with Jill, and third record deals with John. What about features?
Each column is a feature.
Each column is a feature or attribute. Yes, each column is a feature or attribute. Okay, and what about these things like service rating? It should be discrete numerica.
nominal, can we say this service rating?
Nominal, ordinal.
Ordinal.
Sorry, ordinal.
Yeah,
Sorry,
ordinal. What about this one?
It's not categorical, right? Then how do we say it's ordinal, ma'am?
Rating can be 0 to 10, right? 0 to, sorry, not 0, 1 to 10. What suppose if the scaling is like review we will give only 2-star, maximum of 5-star, right? Only 5 categories.
Okay.
So in that case, we can consider that as a categorical. Yes.
Okay, ma'am.
And is priority customer only 2 categories, yes or no?
Yes, ma'am.
It's a binary variable. It's a binary variable or
Nominal.
Nominal. It's in simple general, we can call it as nominal, but we have only 2 categories. So I can represent it's a binary. And what about the card type? You have a platinum card, a gold. We can compare ordinal, right? And what about the credit score? It should be a continuous numeric. And is multiple account holder yes or no? Binary or nominal?
Yep.
Simple. Yes? Yes. And what about the second data type, transactional data? We can have a transactional data. The transactional data can be like purchase 1 and purchase 2, like based on the transaction, right? Each transaction represents one purchase activity here. Each transaction represents one purchase activity. For example, the transaction 1 contains pen, paper, medicine. Yes, for the second record, the transaction 1 contains rice, medicine, vegetable, milk. This is about transaction 2, right? So it's commonly used in market basket analysis, like in the association, like unsupervised learning. We can use this approach, right? If many customers buy milk or milk and bread together, the shop can place them nearby. That is the objective here. So this kind of data are called as transactional data. See here, transaction 1, transaction 2, transaction 3, and transaction 4. From this table, what is your observation? This is for Jack alone. See, this is for Jack alone. Likewise, you will maintain Jill as well as John. Yes?
Yes.
Yes. Yes. See, the vegetables, rice. See, here also the rice and vegetable is there in the transaction 2, rice and vegetable. This is how, see, this is how the model will identify the pattern and it will group together. Okay, if the customer purchased rice, or they will purchase vegetable also parallelly for milk and bread, or even egg and bread. Likewise, see, here we have only very minimal records, only 3 records. It's very difficult to analyze. But the thing is, this is how, with respect to each and every record, the machine will try to understand the transactions, and then it can be utilized in the market basket analysis. So the business people can make a more reliable decision. Okay, so this type of data is useful for discovering the buying pattern or association rules and recommendation, mainly recommendation. If you have a transactional data, in business point of view, you can do some kind of recommendation, better recommendation. Okay. The next thing is about document data. See here, you have 3 documents like D1, D2, and D3. Yes, each and every document is treated as one data object. I hope you are aware. One data object means one record. Yes, the column represents the features or the attributes, which tells us, which represents important words or terminologies. The trend or data, story, mining, cloth. What is this? This is document term matrix. This is document term matrix, right? So it converts text into a numerical data here. Yes. For example, in document 1, the word data appears. The word data appears 10 times. In document 1 itself, this particular word data appears 10 times, right? So the number shows like how many times each word appears in each document. Okay. The number shows. A trend. What about this trend? See, these all are words. Word 1, word 2, word 3, word 4, and word 5. All such words are available in all three documents, and these numbers represents how many times each and every word appeared in a document, right? See, which helps computers analyze the text easily. For example, if the word mining appears many times, just assume, right? For example, if this particular word mining appears many times, the document may be related to data mining, or the medicine words, or some domain understanding we need, right? So the document data is used in text mining, sentiment analysis, or spam detection. Even for spam detection, like for the first mail or second mail, if you have you won the lottery or lottery prizes, likewise, if those words are repeated in nature, in that case you can do you can come up with one conclusion, right? Maybe it's a spam email. Topic identification and search engines, these documents or document data are very helpful, right? So based on the search engine only, we can get the original source data, this kind of document data from the search engine. We can extract such informations, right? So this is about document data. And moving on to the web and social network, what is this? It's a graph. We have four persons: Jack, Mary, Jill, and John. Jack is associated. It's a network, right? Network or graph. Can we say that it's a graph? Vertices are connected with edge, right? So data is represented as a network or a graph where each person is shown as a node. Like each and every person is represented as a node. The person can be connected with another person using a edge connection. Connection between these two persons are called links or edges. See, the Jack is connected to Mary, Jill, and John. Like, for example, you can consider this as a first level LinkedIn connection or Facebook connection, whatever. So each person can also have attribute, which is nothing but a profile values, profile details. Jack has attributes such as industry person, the domain is networking, and the role is analyst, right? See here, the work field, purpose of connect, job search, yes, and domain of work analysis, and number of connections 1, link to parent 1. John is a parent, and for Jack, how many childs? Likewise, you can see from this graph, I have extracted this kind of data. Yes or no?
Yes, ma'am.
Yes. So such,
Yes.
yeah, if you have network related data like this, you can make such graphical representation into a tabular format like this. It depends. Again, the feature selection and how many parents, how many parents are there, how each and every node is connected with each other, what would be the child, for how many childs are there. Likewise, we have to extract the feature based on our domain understanding as well as the problem objective. So this type of data is used for friend recommendation. You can recommend a friend here, right? See, Jack is friend of Mary, as well as Jack is friend of Jill, and Jack is friend of John as well, right? For Mary and Jill, the application or the system can recommend the friend connection. For John, the system can recommend Jill for a friend and Mary for a friend, because these two have mutual friend connection, like Jack, right? Yeah.
Shouldn't be two more rows also for Jill and Jack?
Yes. So this is sample data. Yeah, it's a sample data. I have given only John and Mary alone. Likewise, you should have two more records. A complete record should be altogether. And we have a spatial data. Spatial data is nothing but if you have latitude and longitude in your record, then such kind of data sets are called as spatial data, right? Location. The data is related to location or geographical position, then it is spatial related data. Yes, it's very simple. And what about the time series, like day wise, month wise, or year wise? If you have some profit and credit score, employee attrition rate, likewise, if you have some time, see, whenever the time is the time notion is involved in your scenario or data, right? Here it's time, right? Every month, Jan, April, May, June, July, yes, or it's like a Jan, Feb, March, April. Okay. Every 4 months, we will be having some analysis here, right? Or every month, you can also do analysis. Every week also, you can do some analysis. So all such temporal related data are called as time series data. Okay. So the company can analyze whether the profit is increasing, whether the employee attrition rate is reducing, or how credit score changes over a time, right? So such kind of analysis can be done with the help of this kind of time series data. And what about the sequence data? See, which means data arranged in a specific order where the order of value is very, very important here, right? So this particular image shows a DNA or gene sequence pattern where the biological letter such as A, biological letter like such as A, T, G, and C appears in order. Are you able to see here? G, C, some order. Are you able to see here? I think it's not visible properly. Like A, T, T, C. These all are orders, biological letter orders, right? So this is about your sequential data. Each symbol in the sequence has some meaning, right? Only when it is positioning and position and orders are considered. If you are considering this order, what suppose if ATT for this particular combination and order, you will be having some meaning, different meaning, or GCC, you will be having some different meaning, right? Unlike a normal table data, sequence data focus on what comes before and after each value. I will give you one more example for sequence. It's a very complex example, right? In the NLP domain, what suppose if I have given Google, I hope you all used Google Translate, right?
Yes, ma'am.
Yeah. How are you? If I want to translate these three words into a Tamil or English or Hindi or whatever language, another natural language, right? Whether the system will translate how separately or separately, you separately?
It will take the context, then I
Yes.
think it will.
Yeah.
No.
But
Lexical
yeah,
analysis.
no, the thing is, it should consider the entire input as a sequential input.
Tokens,
W1,
yes.
Yeah.
W2, W3 all together. Then only you will get a more context, you will get a translated information and a more context, meaningful translation. Otherwise, you won't get a meaningful translation. Yes. The window size, the size is like whether do we need to consider 3 consecutive words or 30 consecutive words. It depends on the architecture, right? Either you can use the short-term memory or long-term memory. All such concepts are comes under deep neural network, deep learning approaches. Do you have any parallel course for deep learning?
Yes, ma'am.
Yes,
Yeah,
ma'am.
they will discuss about RNN, recurrent neural network, to remember this short-term memory, or long-term memory means LSTM or encoder decode. There are a lot of algorithms in deep learning approach to maintain such information. But our focus is, I just wanted to disseminate all such different data types. But our focus is what? Relational. Structured data, especially structured data. Okay. In the next class, we will start with the data case study as well as the data pre-processing technique, so that I can, even if time permits, I'll execute some code as well for implementation purpose. Okay. Okay. Only 50% completed. Yeah. Any queries? If no queries, we can wind up the session.
Ma'am, there are many characteristics, right? So one question is like when we predict or analyze or train model, etc. So these characteristics will be in only any of them, or there might be multiple also will be
Yes,
part of
there
it?
might be multiple.
Multiple also, right? Okay.
The characteristics means you're talking about the different types or the dimensionality,
The data types.
Data,
Types.
yeah,
Just now
yeah.
which
You
can.
can, yeah, you can it could be a transactional data. If it is arranged in a tabular format, then it comes under relational or object type only, right? The transaction data can be arranged in a tabular format, right? Document data can be also arranged in a tabular. It could be a combination.
Okay.
Yes. I'm not sure whether I can start linear regression by next class, but try to study about the linear algebra. Yes, vector, scalar. I'll post it here. Algebra, vector representation, the difference between scalar, vector, okay? And then linear equation, linearity, linear versus non-linear. With respect to maths, you can start study about such line
Can you go to
equation.
hello, ma'am?
Yes.
One question. Then can you go to that slide where you mentioned linear regression?
Linear regression. Okay.
Yeah, that where like question and answers, what kind of data it is.
This one. Or this one.
No, like below where we had that example that this is the kind of data and how do we define just below like
Yeah, I'll move here.
yes, and there above, yeah.
This one.
Above.
No.
No, where we had that. Let me
Tell me the topic.
Yeah.
This one. Data types. So this one. Ordinal binary. No.
Where you mentioned that this is the type of data, so this is linear regression.
Type of data, linear regression. Very first slide.
No.
That slide, ma'am, I believe.
This one.
Okay, I forgot, I guess. Like you mentioned that.
And
Maybe
slide number
that
9.
ML workflow.
Slide 9.
Yeah,
9.
slide 9.
This one. Question 1, question 2. Okay. Yes.
Yeah. So how do we define that this is linear regression, or what is that? A given problem is of.
Classification.
Yes,
that
ma'am.
is. Yeah. Second. It's very simple. Depends on your y variable. See here. It depends on your y variable. Where it is. You can categorize whether it is regression or classification. Okay, see here. If your y is, what is your y here? Car price, right?
Yeah, this one. Yeah.
Yes. What
How do we
suppose?
choose?
Yeah. What suppose? Instead of y, that is what? The number. The values are continuous real number. Yes.
Continuous real number. Yes.
Yeah, floating point, right? Continuous real number. Hence, we are supposed to use regression only, right? Instead of car price, based on the mileage, if I ask you to predict or if I ask you to categorize your y variable is whether will you purchase this car or not? Yes or no? In that case, your y is categorical. Depends on the type of data. Depends on the type of data of your target, we can select the task. If your y variable is labeled data, the label data is continuous variable, then it is regression. If your labeled data is categorical in nature, then you are supposed to adapt classification. Okay.
The target can be single at a one time, or it will be multiple objective.
Sorry.
The target column, it should be one at a time, or it will be multiple. We can choose multiple objective.
Only one objective at a time. See, the thing is, for a single problem statement, you can perform multiple tasks, right? But one objective, one task at a time.
Okay, thank you.
You can use the same input for classification as well as regression, but the approach should be one at a time. Okay. I think Ganesh Kumar. I think I know him, like.
Yes, ma'am.
Are you old student or the previous semester? I'm
Yes,
not
yes,
sure.
ma'am. I took a break. Yeah.
Sorry? Oh,
Yes,
break.
ma'am. I took a break. Yeah.
Yeah. I think I saw you in the
Yeah,
previous
yes.
class.
Yes,
Yeah.
ma'am. Yeah.
Okay, fine. Thank you all.
Thank you,
Ma'am,
ma'am.
what does that objective function here mean in the slide that you were sharing?
Yes, objective is, that is what we have not yet started mathematical approach, right? Objective means like, okay, what is your objective if I ask you to take a route from your home to office? What is your objective? You will prefer?
Shortest distance.
Shortest distance. Their objective function is minimization. Yes. If you want to get profit, if your scenario is totally different from this to another scenario, right? Like profit or loss. If we talk about profit or loss, right? For profit, we always expect the maximum profit. Their objective function is maximum. Yes.
Okay.
For loss, we should use the minimize. We want to minimize the loss function, but we want to maximize the accuracy. It's a vice versa. If you are trying to increase the accuracy, your loss should be minimized. If you are minimizing your loss or error, obviously the accuracy will be increased. That is what objective function.
Ma'am, on that where we were plotting the this graph, right, where you were mentioning about y is equal to mx plus c or hypothesis one. So on that, you briefly mentioned that let's say there are two data points. One is the weight and one is the height. So there is no relation between those two, and we'll scale it down. Can you expand on that part?
No. That is, see, it's totally out of scope as per today's session, right? I just wanted to give you the notion behind that. Don't worry, we will discuss such topics elaborately in the upcoming session. Feature selection, feature scaling, and down. Everything is there, right? I'm supposed to finish today, but still we covered off of the slides. Okay.
All right. Thank you.
Yeah. Thank you all. Yes.
One question here. Ma'am, are you there?
Yes, please.
So, you said that when data is continuous, we go for regression, but when data is categorical, we go for classification. That's correct, right?
Yes.
So, and categorical data consists of yes or no or good, better,
Good,
best, something
better,
like that,
male,
right?
female, different types of flowers, rose, something like that. All category.
Okay. So, ma'am, in case we are assigning rating, 1 star, 2 star, 3 star, that will come under categorical only, right?
Yeah. If I ask you to predict if I ask you to review rating, right?
Yes.
Yeah, it's a
Okay.
category.
Understood, ma'am. Yes. And for continuous, you gave an example of car price being a different
Price, height, weight.
Yes,
See,
right.
there will be some range. Like height can be in centimeter, like 135 for adult, 135 to 175. But in between, there will be more number of values. There should be some interval, but there will be a more number of values. It's an interval, like continuous values.
Okay. So, in case if we classify it as 10 lakhs to 15 lakhs, these cars are present, 15 to 20, these are present, then that can be considered as categorical, and we can go for classification also, right?
Yes.
Okay. Okay.
Okay.
Thank you.
Thank you all. It's all almost 12:40.
Thanks, ma'am.
Thank you, ma'am. Thank
Yeah,
you.
thank you.
Thank you, ma'am.
Yeah,
Thank
I
you,
have
ma'am.
back-to-back class. 1:30.
Thank you,
After
ma'am.
having my lunch, I have to start. Yeah. Thank you all.
Take care, ma'am.
Thank you, ma'am.
Yeah. Bye.
Thank you, ma'am.